Yes, class. So in the last class, we had started with specific heat capacity. So what was specific heat? Specific heat capacity. This was basically the amount of heat that was required to raise the mass of 1 kg, that is unit kg, through 1 Kelvin or 1 degree Celsius. So we got the formula delta Q is equal to MC delta T. So I think we used also this formula. 1.68 into 10 to the power 6 we got. All right. So we simply use the formula delta Q is equal to MC delta T. Molar heat capacity will be molar heat is defined as amount of heat required to raise the temperature. Now see here, what is the difference? No, when this was for 1 kg, we called it as specific heat capacity. When this is for 1 mole, we'll call it as molar heat capacity. That is the only difference. So here delta Q instead of MC delta T, no, because mass is not involved here, we'll write NC delta T. N will be the number of moles. Fine, because this is molar specific heat for liquid also, for solid also. This formula you will use. If 1 mole is there, or if mass is given, directly mass is given, then you will write delta Q is equal to MC delta T. Now N is what? And here is number of moles. And what is C? C is the specific heat, molar specific heat we'll say. Specific heat capacity was for mass 1, MC delta T1. This is molar specific heat. Fine. So C is equal to delta Q divided by N delta T. This will be the value. So if number of moles is 1, temperature is changes 1 Kelvin. So whatever amount of heat will be equal to molar heat capacity. So what is the SI unit for it? SI unit is joules per moles per Kelvin, and CGS unit will be calorie per mole per degree Celsius. Fine. Note it down. One numerical also we'll see based on this direct formula based numerical. I think you should try also that once. Try this first by yourself, then I'll discuss it. Based on this this formula, the way we did it in the last class. Yes, Devangi, answer is right. 2.3 into 10 to the power 4 joules. See here, you will use the same formula. Delta Q is equal to NC delta T. N is given to 2 moles and C is given as 2.3 into 10 to the power 2, right? And change in temperature is 50. 60 minus 10, this is 50. So this is equal to 2.3 into 10 to the power 2 joules. Fine. Now, one more quantity you have similar to this. This is specific heat of water. So when you are talking about the same specific heat capacity only, but you're just referring to water, there is no other material except for water. Fine. Just if you, when you're referring to the same thing, amount of heat required to raise mass of 1 kg of water through 1 degree Celsius, same thing. Not 1 gram, make it 1 kg. This is 1 kg. 1 kg of water. In SI unit, it will be same thing. See, so this value is fixed. You have to remember this value, 4200 joules per kg per Kelvin. Remember this value. Fine, specific heat of water. Remember this value. And one more thing you have, heat capacity. This is thermal heat capacity. When you are not specifying mass, this is what? See, in the formula, delta Q is equal to MC delta T. This part, MC, this I am writing as S, specific heat. So MC, I'm writing as it as specific heat capacity. MC is equal to S, which is the specific heat capacity. So when you are not figuring it out, product of mass into the value of specific heat capacity is known as thermal heat capacity. All right. So specific heat of water was CW. Everything will be the same, MC delta T, wherever, whichever quantity is getting used directly with this. And see one more thing here, SI unit will also change. SI unit will be joules per Kelvin. And this is CGS unit. This is calorie per degree Celsius. All right. One more thing, class. You might need to convert 1 calories into joule. So 1 calorie is equal to 4.186 joules. So we, mainly for our calculation, we write it as 4.2 joules only. This part. Fine. One more numerical, I think, is there. First note it down, then practice that numerical. So directly questions will be there only. Delta Q is equal to MC delta T, NC delta T, NCW delta T, S delta T. This is the question. Calculate the heat required to raise the temperature of body from 10 degrees Celsius to 110 degrees Celsius. So S is given. You have to find out the heat required. Delta T is the change in temperature. Yes, right. It will be a positive value because you will subtract higher from lower one. Yes, right, Devangi. See, calculate the heat required to raise the temperature of body from 10 degrees Celsius to 110 degrees Celsius. So delta Q is equal to S delta T. Delta Q. So value of S is given as 2000 and delta T is given as 110 minus 10. This is equal to 100 degree. So this multiplied by 100, this will give you 2 into 10 to the power 5. Fine, so all the values are same. Now also one more topic we are going to do, water equivalent. That will also be having similar formula. Note it down, then we'll discuss that. See here, now the similar term we have, the way we had no specific heat capacity for water as 4200. Same thing, thermal heat capacity also we have for water. Right? Delta Q is equal to MC delta T. So now M into C, this is just for water, mass of water into specific heat capacity of water. This is equal to, we'll just call it as W. So it is exactly this term. See what all formula we have done. Delta Q equal to MC delta T. We did this. Then delta Q is equal to NC delta T. Then we combine M and C and we got thermal heat capacity. The value of C for water, that was 4200. Now we are writing delta Q is equal to same thing S delta T, but this S is for water now. This S is for water. So whatever mass of water is given to you, multiplied with the specific heat of water, and that you know already 4200. So this is exactly just specifying this term for water. It's like you're putting delta Q is equal to M C delta T. So C will be C of water, like this. Now this question based this. Plus, calculate the heat required to raise the temperature of copper from 10 to 6. You use the same formula, delta Q. This is equal to W delta T. So W, here you have to find out heat. Mass of water, this is already given. And 10 to, it has 10 or 70 into 50. So 500, but unit will be in grams only. So unit will be calorie. Okay. C class. This is one more important topic, latent heat. Here what will happen is this is basically amount of heat that is used to change the state. You have no states of matter, vapor, you have liquid, you have solid, you have. So when state change, you will use latent heat. All right, because in combined question, no, one place you will have to use MC delta T and at one place you will have to use ML. So it will be confusing because in both the cases you are getting heat. So how to identify? Remember this way only. Temperature change. So you will use delta Q is equal to MC delta T, specific heat capacity. Fine. And when it is change in state, you will directly use ML, mass into latent heat. Now, latent heat is what? It is the amount of heat to change one state into another state. Like, see, this is one very good flowchart that we have. Look here, minus 10 degrees Celsius is ice. When heat is given to ice, so 0 degrees Celsius is ice. Then again, heat is given. So see here what happened. When heat was initially given to ice was at minus 10 degrees Celsius. Okay, so we have started from here, minus 10 degrees Celsius ice. When heat is given at this particular point, at this particular stage, see what happened. Initially, ice didn't become water. It was temperature that was brought to 0 degree value. So it was change in temperature. So you will, if I ask you what is the value of heat here, you will simply use the formula MC delta T. Whatever quantity, mass and M and C for ice are given in change in temperature. Now look, when further heat is given, what is happening here? 0 degree and 0 degree, these are remaining the same. Ice has been converted into water now. Temperature is same. It was 0 degree ice. Now it is 0 degree water only. But it is from ice, it has changed its state to water. So here you will find out the heat by using ML. Here if you will know, if you will directly use delta T, you will not be getting your answer. Delta T will be 0. 0 minus 0 will be 0. So when you will provide heat, fine, when you will provide heat, the state will change. So from minus 10 degrees Celsius, it was ice, heat was given. 0 degrees Celsius heat, ice, then again heat is given, 0 degrees Celsius water. Then again heat is given. Now what is happening? C class again, water is remaining water only, and the value is reaching the boiling point of water. So initially we had minus 10 degrees Celsius of ice. Now what is happening? Change in temperature. Fine. So water is remaining. So since state is remaining the same, there's a change in temperature. You will say this is specific heat capacity one. You will use delta Q. How will you find the heat change? You will use it by using delta Q is equal to MC delta T. Now 100 degrees Celsius of water is there. Heat is given. Now what will happen? 100 degrees Celsius is achieved. So it will not change further, but it will change its state. From water, it will become steam. Fine, 100 degrees Celsius of water, it will become 100 degrees Celsius of steam. So wherever the state is changing, there is no change in the temperature. And whenever temperature is changing, there is no change in the state. So accordingly, you will use the formula. So minus 10 degrees Celsius ice was given heat and it became 0 degrees Celsius ice. This you have to learn, class. Learn this along with me only. This you have to write in most of the questions. So minus 10 degrees Celsius of ice became 0 degrees Celsius of ice. Further heat was given, it became 0 degrees Celsius of water. Further heat was given, it became 100 degrees Celsius of water, and further heat was given 100 degrees Celsius of steam. Fine. Now there are certain conversions and just names you should remember, because in your questions names can be given. When a solid is converted into liquid, we say it is melting. Ice is converted into water, we say ice has melted. And when liquid converts it into solid, we say it is freezing. When even water we freeze it, then we only obtain ice. So melting, freezing. Then you have liquid into vapor. When directly liquid becomes vapor, we say it is vaporization. And when, like similar procedure which we have, how the water evaporates and then it becomes water vapors go and form cloud. But when the cloud gives rain back, So what happens? It is the condensation of clouds that occur. So when vapor into liquid, it is condensation. And when solid without going into liquid state directly converts into vapor, we call it sublimation. And opposite is known as anti-sublimation, solidification, or deposition. So why these basic scientific names are given? Just in case any question is asked. So you should be able to identify it, right? So during state change, heat energy is used in changing interatomic separation, no changes in change in temperature. Same thing. I'll go to this first. I think you should note it down. Note down this part. And this is important, class. Please remember and mark when you are writing that this is important. This change of heat, ice into steam at least. Not all ice into steam, you should know. You'll get a graph also that I'll discuss later. C class. Now latent heat are also of two types. Fusion and vaporization are the only ones that we have to do and discuss. Rest of it is not a part of the syllabus. So just remember, when solid is converted into liquid, that amount of heat will be called as latent heat of fusion. And when your liquid is changing into vapor, you will say latent heat of vaporization. So here also delta Q will be equal to ml only, but we'll use mlf. You will see F is written in the subscript, in the textbook also, in questions also. That is just signifying that this is for fusion. Same way, delta Q is equal to ml delta V. Like this will be for vaporization. And this will be for vaporization. All right. Sublimation is also there. Sublimation also is sometimes given. C part you can add, because in some questions sublimation can also be given. So same thing, delta Q is equal to mls sublimation. So L will be equal to delta Q divided by M. So that is joules per kg. So, and so SI unit will become, see, SI unit will become joules per kg. And CGS unit will become calorie per gram. Fine. Now, very basic questions we'll do. Then I want to show you that graph. That plotting of graph thing is more important. So do this question, then I'll share with you that. One or two questions, let's do. First, note it down. See, CGS unit means SI unit means standard international unit. That is fixed. So that no one unit is specified. You get your answers standardized everywhere. Because if you get your answers, let's say in millimeters, you are getting for distance. I am getting in inches. Someone is getting in meters. So which value to accept? All the values must be correct. All can be converted into each other. So that standard value that yes, every answer has to be in its SI form, basic simple form that will be accepted, is done by SI unit. Now, when you have one more unit of system, that is centimeter, gram, and second system. So SI units conversion, it is only centimeter, grams, and seconds. This is also specified, just it is below. Look, this is just below the SI unit. So either you use SI unit, and when you use CGS unit, every unit will be in CGS unit. So in centimeter gram scale, some others were also added, like for joules, calorie was given, right? So for other values, these were kept on giving. See, to calculate the latent heat required to melt 10 kg of ice, LF is given 3.3 into 10 to the power 5. So ice is getting converted into water, and fusion is also given. So simply you will put delta Q is equal to MLF. That will be 10 into 3.3 into 10 to the power 5. So this becomes 3.3 into 10 to the power 6 joules. Similarly, the other question says latent heat to vaporize. So same thing, delta Q will be equal to M LV. This will be equal to mass is 100. LV is 22.6 into 10 to the power 5. So this is equal to 22.6 into 10 to the power 7 joules. Note it down, then that graph I'll tell you. That graph can be asked separately as well to you. See, class, this is how you will represent it graphically, that conversion of which I have told. Same thing. So since ice was here, minus 10 degree of Celsius of ice, so here it is the starting point in the negative y-axis. Now what has happened? Temperature has increased, state hasn't. So temperature increases to 0 degrees Celsius. Now temperature remains the same. See, state is changing. Then temperature increases, state remains the same. State is changing, temperature is remaining like this. Now on this you also have questions also, and in combination of these you have one we are going to discuss, one question. This is an important question that we'll discuss. Do one thing, write down everything together. Let me discuss this with you first. See here, calculate the heat required to convert 3 kg of ice as minus 12 degree Celsius kept in a calorimeter to steam at 100 degrees Celsius at atmospheric pressure. Specific heat, heat of ice, specific heat of water, latent heat of fusion, latent heat of steam, all these are provided to you. The way in the example I had taken minus 10 degrees Celsius. Here it is minus 12 degrees Celsius. Same thing. Fine, minus 10 degrees Celsius, minus 12 degrees Celsius. So let me draw that only. So you have minus 12 degrees Celsius. This is ice with you. So let's say initially Q1 is given. This gets converted 0 degrees Celsius of ice. Now what will happen? Again, some heat is given 0 degrees Celsius. Then water. Delta Q3. Now what will happen? This will be 100 degrees Celsius. And this will still remain water. Finally, Q4 will be given. This will be 100 degrees Celsius of steam. That is what was required at the last, right? To steam. Ice to steam. All right. So what is the net energy? What is the total energy? See here. Total energy, heat will be Q1 plus delta Q2 plus delta Q3 plus delta Q4. Fine. Now see, Q1, we'll use MC delta T, right? Temperature is changing. So it will be MC. Delta T will be what? Final is 0 minus initial is minus 12. This is Q1 plus Q2. Here state is changing, so I'll use ML. And this is fusion plus again MC delta T, MC into delta T is what? Final minus initial. Then again, I will use ML, but this will be vaporization. Now, see class one thing, mass can be taken common from all of it. Mass I can take common. So that will be 12C plus latent heat of fusion plus 100C plus latent heat of vaporization. So mass is 3. This was 2100 plus, what is this value given? LF 3.35 into 10 to the power 5. So this is 3.35 into 10 to the power 5 plus 100 into 486 plus 2.25 into 10 to the power 6. So this will be the final answer for this question. Just check and let me know. It should come around 9.08 into 10 to the power 6 joules. So like this, you will be getting whole complete formula. Anything can be given. This is just same method that you have to apply. Basic trick will be as it is. Above part you have written already. Note it from here. Any doubts you have, you can ask me. Fine class then. All those who have completed, you can leave. Now calorimetry. And one more thing class. Yes, before leaving. You have your class on Friday. I hope you know. I just for these 2 Mondays, no, the Monday we already had, that Monday and the coming Monday. I'm not able to take class. I will not be able to take class on the Monday, both the Mondays. So I'll take class for Friday. So just 2 days we have. So we'll have the class on Friday now. Okay, class. Thank you so much.
Thank you, ma'am.